As Cool Cosmos website writes, Earth moves very fast. It spins at a speed of about 1,000 miles per hour.
Hello.
Orbits
Hey, what's up?
Nothing B.
67,000 miles per hour.
Watching Dubay.
We do not
Having a
feel
bud.
any of this motion.
What's up with you?
Nothing. Watching the game, having a bud.
If your speed
True.
changes.
True.
For example,
What's up?
which is moving
What's
at a
up? What's up? You'll probably need a few of these. Today we're looking at Eric Dubay. I want to give massive thanks to all of my supporting members and patrons. Thank you all so very much. So it seems that Eric has got himself all in a spin about spin. Better tell us about it, Eric.
Roll VT.
Consult any mainstream science publication,
It's only worth consulting them if you actually understand what they're saying.
or ask any science teacher,
It's only worth asking them if you actually listen to what they reply.
why can't we feel the Earth spinning? And they will unanimously reply
You've been eating crayons, Eric, but you're not getting enough greens.
that it is because the globe spins at a perfect constant speed, and we can only feel acceleration or deceleration.
That's correct, Eric. You don't feel speed, you feel changes in velocity.
As Cool Cosmos website writes, Earth moves very fast. It spins at a speed of about 1,000 miles per hour and orbits around the Sun at a speed of about 67,000 miles per hour. We do not feel any of this motion because these speeds are constant.
It's correct that we don't feel that rotation, but it is measurable.
You can only feel motion if your speed changes.
Yes, Eric, don't labour the point.
For example, if you are in a car which is moving at a constant speed on a smooth surface, you will not feel much motion. However, when the car accelerates or when the brakes are applied, you do feel motion.
And this is a gorgeous and famous example. These items are balanced while travelling along at great speed, but at a constant velocity.
The glaring problem with this claim, rarely ever addressed,
Wait for it.
is that the globe and everything on it, if it existed, would be undergoing constant acceleration, because uniform circular motion is constant acceleration.
Yes, there's a constant acceleration downwards, the centripetal force. You know, gravity.
Uniform circular motion can be described as the motion of an object in a circle at a constant speed. As an object moves in a circle, it is constantly changing its direction. At all instances, the object is moving tangent to the circle. Since the direction of the velocity vector is the same as the direction of the object's motion, the velocity vector is directed tangent to the circle as well. An object moving in a circle is accelerating.
Yes, travelling in a circle, at t0 we have velocity 0, at t1 we have velocity 1. You sum those vectors, and the difference between them, the delta, is the acceleration of which you speak.
An object undergoing uniform circular motion is moving with a constant speed. Nonetheless, it is accelerating due to its change in direction. The direction of the acceleration is inwards, with the inward net force directed perpendicular to the velocity vector. The object is always changing its direction and undergoing an inward acceleration.
An object in motion remains in motion unless acted on by an outside force. So yes, if you're stood on the surface of a sphere which is rotating, you travel in a straight line. You would travel on in that tangent line unless you're acted on by another force. That force is a centripetal force. It's changing your direction to follow the surface of the sphere. As I said, that's gravity.
Therefore, the globe's theoretical astronomy is at odds with demonstrable physics. Uniform, and even more so with non-uniform, circular motion creates a centripetal force which entails constant acceleration in constantly changing directions.
No. You're just wrong, Eric. You travel in a straight line unless acted on by a force. That force is the centripetal force. It's the force that is pulling your journey into a circle. The other force you're talking about is the fictitious force of centrifugal force.
The heliocentric model claims the Earth rotates in uniform circular motion at a constant speed.
Yes, a constant speed of 1 revolution per day, 0.006944 revolutions per minute,
while revolving an elliptical orbit around the Sun at another constant speed
of 1 revolution per year,
while the entire solar system makes a circular orbit around the Milky Way galaxy at another constant speed
of 1 revolution
per 250 million years.
And the Milky Way galaxy shoots off in a straight line from their Big Bang beginning at yet another constant speed.
Well, since that's as near as damn it a straight line, the fact it's 670 million miles per hour shouldn't matter, because you've already said we don't feel speed.
In other words, we are actually supposedly undergoing 4 different circular, elliptical, and straight line motions simultaneously, but being told that we, quote, do not feel any of this motion because these speeds are constant.
Have a look at this fairground ride, Eric. In the UK, this is called the cage. You're rotating. The centripetal force is provided by the walls of the cage. Your body wants to carry on in a straight line, but the walls are preventing it. You experience the fictitious centrifugal force. You can feel it because that's rotating quite a few times per minute. Now, if you slowed that ride down so it rotated once per day, do you think that these people would still stick to the walls of the cage? No. If that was rotating once per day, you wouldn't even feel the rotation. All those people would just be in a heap at the bottom.
They always give the example of a car or train going straight at a constant velocity and claim we cannot feel that motion. But what if the car is speeding along an elevated, uniform, circular racetrack, while that entire elevated racetrack is making an elliptical circuit around the racing grounds, while simultaneously the entire racing grounds themselves are on a gigantic moving circular foundation, while that foundation itself shoots straight off into the universe?
Well, Eric, you, like all the other flat earthers, get all scared by big numbers. We've already established that the speed itself doesn't matter. It's the change in velocity. So if you were sat on the equator, in a period of 24 hours you would travel 24,901 miles to carry out a circle of 360 degrees. Every hour you have travelled 1,037 miles, which is about 15 degrees per hour. Thanks, Bob. So each minute you're travelling 17.3 miles, about 0.25 degrees. That's your change in the direction. So your velocity is changing every second. Each second, Eric, you're experiencing an angular velocity of 7.29 times 10 to the negative 5 radians. It is minuscule. However, it is real, and so therefore we should see a measurable effect. So if you take a man or woman with a true mass of 100 kilograms and sit him or her on the equator, he or she should feel as though they're being flung outwards by this terrific change in velocity. And indeed, he or she should experience a reduction in their weight. They still have a mass of 100 kilograms, but their weight will have reduced. And indeed, this is the case. The weight of that 100 kilogram man or woman will now register 0.34% less, about 340 grams. So what your Dunning Kruger misunderstanding is saying, Eric, is that if we took you to the equator and sat you on one side of a set of scales, and on the other side we placed one of these, it would fling you off of the Earth's surface and out into space. Eric Dubay, you have just been debunked by a 340 gram tin of Happy Cow Austrian processed cheese.
So the next time someone claims you cannot feel the Earth's motion because it spins at a constant speed, remind them that
Eric Dubay really hates cheese. Until next time, stay sensible.
Shut up and sit down.